Why are we seemingly alone in the cosmos, despite the staggering number of stars and planets? This question, which has intrigued and puzzled humanity for centuries, is at the heart of the Fermi paradox. Named after the physicist Enrico Fermi, this paradox grapples with the contradiction between the high probability of extraterrestrial life and the lack of contact or evidence for such civilizations. But to fully grasp the weight of this paradox, we must first take a moment to consider the vastness of our universe. Picture a cosmos teeming with an estimated 2 trillion galaxies, each containing millions, billions, even trillions of stars. Around these stars orbit countless planets, many of which reside in the so-called Goldilocks zone, where conditions could be just right for life as we know it. Given these astronomical numbers, the odds seem in favor of life existing somewhere out there. And yet we have no definitive proof, no clear sign of any civilization beyond our own. This is the enigma that is the Fermi paradox. It's a riddle that forces us to question our understanding of the universe, our place within it, and the very nature of life itself. Are we truly alone? Or is there something we're missing, some fundamental piece of the puzzle that could explain this deafening silence? Over the years, many theories have been proposed in an attempt to solve this paradox. Some suggest that we might be alone, that Earth is a rare gem in a universe filled with barren worlds. Others propose that life is common, but advanced civilizations are not. Perhaps they're avoiding us, keeping Earth in a cosmic quarantine. Or maybe they've transcended our reality in ways we can barely comprehend. As we delve into this cosmic mystery, bear in mind that these are not definitive answers, but rather speculative solutions. They're ideas that push the boundaries of our knowledge and imagination, challenging us to rethink our understanding of the universe and our place within it. Today we explore 4 plausible solutions to this cosmic conundrum. Scene script. Firstly, perhaps life is not as common as we think. Welcome to the Rare Earth Hypothesis. The Rare Earth Hypothesis. It's a proposition that suggests the emergence of intelligent life isn't as simple as having a few good conditions in place. No, it argues that the birth of conscious beings is an event of astronomical rarity, a cosmic lottery of sorts. Let's delve into this a bit more. The hypothesis implies that the conditions necessary for intelligent life are incredibly scarce in the universe. It's not just about having a planet in the Goldilocks zone, where it's not too hot nor too cold for liquid water to exist. It's about having a perfect blend of many factors all happening in the right sequence at the right time. Consider Earth. Our home planet orbits a stable star, has a protective magnetic field, and a moon to stabilize its axial tilt. It's located in a relatively calm neighborhood of the galaxy, safe from supernovae and gamma-ray bursts. It has plate tectonics, which helps in climate regulation and nutrient recycling. And don't forget about the right amount of certain elements like carbon and oxygen. But even if a planet checks all these boxes, there's still the matter of time. Life on Earth took billions of years to evolve, from simple cells to complex beings capable of pondering their place in the universe. That's a lot of time for things to go wrong, from asteroid impacts to global ice ages. So, when we consider all these factors, the Rare Earth Hypothesis suggests that the odds of all these conditions occurring naturally, in the right sequence, and surviving long enough to give rise to intelligent life are staggeringly low. It's a sobering thought, isn't it? Perhaps we're not just one of many civilizations in the cosmos. Maybe we're among the very few, or even the only one. A result of a cosmic roll of the dice that may not have happened anywhere else. So are we just a cosmic fluke? Next, we encounter a more ominous possibility, the Great Filter. The Great Filter theory presents a rather chilling explanation to the eerie silence of the cosmos. It proposes a metaphorical wall, a barrier on the path from pre-life to a Type 3 civilization, a civilization capable of harnessing the energy of an entire galaxy. This wall, this great filter, is something that all attempts at life might inevitably crash into. Imagine a cosmic obstacle course where life has to navigate around various hurdles. It starts with the formation of habitable planetary conditions, then the leap from non-life to life, followed by the development of complex multicellular life forms, and so on. Each step is a filter, with the Great Filter being the most formidable of them all. The theory suggests that somewhere along the line, there is a stage so devastatingly difficult to pass that it prevents civilizations from becoming advanced enough to communicate with us. It could be anything from a self-annihilation event, like a nuclear war or a biological disaster, to a natural catastrophe like a supernova explosion or a gamma-ray burst. The unsettling part of this theory is not knowing where this filter lies. There are two possibilities. The first one is that we, as humans, have already passed it. Perhaps the emergence of life or its evolution into complex forms is the rarest of cosmic miracles. If this is the case, then we might indeed be alone in the universe. The second possibility is far more frightening. If the filter is yet to come, then our civilization is doomed to hit this insurmountable wall. This would mean that advanced civilizations are rare not because life is uncommon, but because it tends to destroy itself before reaching out to the stars. The Great Filter Theory is a humbling reminder of the precariousness of our existence. Whether we have already passed this cosmic trial or it lies ominously in our future, remains one of the greatest mysteries of our time. Have we passed the filter, or is it yet to come? Thirdly, what if we are not alone, but merely contained? Enter the zoo hypothesis. Imagine for a moment a cosmic zoo. A universe where intelligent life exists, teeming with civilizations far advanced beyond our own. These extraterrestrial entities, aware of our existence, choose to observe from a distance rather than interact. This is the essence of the zoo hypothesis. The zoo hypothesis suggests that we, on Earth, are like animals in a vast universal zoo. Our extraterrestrial spectators, driven by an advanced ethical code, perhaps akin to our own principles of not interfering with wildlife in a natural habitat, have decided to leave us undisturbed. They watch and study us much like we observe animals in a zoo, respecting our natural development without their interference. This theory addresses a key question of the Fermi paradox. Why, if advanced civilizations exist, have they not contacted us? The answer, according to the zoo hypothesis, is quite simple. They have chosen not to. Consider the motivations of an advanced civilization. They would likely have overcome many of the challenges we currently grapple with. Energy production, disease, perhaps even mortality. Their interests would be fundamentally different from ours. Contacting a less advanced civilization like ours may not offer them any substantial benefits. Moreover, they might be wary of the potential harm that could result from such contact, both to us and to themselves. The zoo hypothesis also introduces the notion of a prime directive, or a galactic code that prevents advanced civilizations from interfering with lesser ones. This concept, familiar to fans of science fiction, posits that non-interference is the best course of action to allow for the natural evolution and development of civilizations. While the zoo hypothesis might seem far-fetched to some, it is one of the many attempts to solve the enigma of the Fermi paradox. It ponders the silence of the cosmos and provides a plausible explanation for our seemingly solitary existence in the universe. Are we just an interstellar exhibit? Lastly, could civilizations be disappearing into a post-singularity black hole? The Transcension hypothesis awaits. The Transcension hypothesis is a profound notion that proposes an intriguing solution to the Fermi paradox. According to this idea, advanced civilizations might become so technologically advanced that they eventually leave our universe, effectively becoming undetectable to us. This hypothesis is rooted in the concept of a technological singularity, a point in time when artificial intelligence surpasses human intelligence, leading to an explosion of technological growth. This unprecedented acceleration could yield advancements so profound and beyond our comprehension that they might appear almost magical to us. At the heart of the Transcension hypothesis is the idea that a civilization reaching the singularity might develop the ability to create and manipulate microscopic black holes. Harnessing the immense power of these black holes, the civilization could potentially create a sort of wormhole to another universe or dimension. This could be a one-way ticket, a transcension from our universe, leaving no trace of the civilization that once thrived. The implications of this hypothesis are staggering. Could it be that the cosmos is teeming with advanced civilizations, but they've all transcended beyond our universe, leaving us to ponder their eerie silence? It's an idea that challenges our understanding of reality and our place in the cosmos. It also suggests an intriguing possibility for our own future. As we hurtle towards our own technological singularity, might we too one day vanish into the cosmic ether, transcending into another realm of existence? If so, what wonders await us beyond the boundaries of our universe? This is the tantalizing promise of the Transcension hypothesis. It's a solution to the Fermi paradox that doesn't just explain the silence of the cosmos, but also paints a future of infinite possibilities for humanity. Could we be on the brink of transcending our own reality?